Good afternoon, everyone. Assalamu alaikum. Today we'll start block 4, and the first topic in block 4 is static electricity or electrostatics. The term electro, or it's from the charges, and static means when they are at rest. So when the charges in this part, you will study when the charges at rest, different phenomena related to the charges. So first thing, what is the origin of these charges? Like, as we know, the structure of an atom, the central part of an atom, which is a nucleus. This nucleus consists of subatomic particles such as neutrons and protons. So these are the subatomic particles, neutron and proton. The neutron does not carry any charge. It is a neutral particle. And a proton, which is inside the nucleus, it carry a positive charge. And around the nucleus, there is another subatomic particle which is revolving around this nucleus in a definite region. And this definite region, what we call this definite region, we call that as shell. And inside this shell, there is another particle known as electrons. So electrons are actually revolving around the nucleus. What is the charge? Like, what is the nature of the charge? Neutron is neutral, proton is positive, and electrons are negatively charged. Now, what happened? Because normally for an atom, when there is an atom, the number of protons are equal to number of electron. So if number of proton and number of electron are equal and proton and electron carry the same amount of charge, the charge which one electron carry, exam point of view, you don't have to learn this value, but it is better you remember these values, as in A levels you will frequently use these numbers, so it's better you remember these values. But for exam point of view, you don't have to memorize this. So when one electron is there, one electron carry 1.6 into 10 to the power minus 19 coulomb. So unit of the charge is coulombs and is denoted by C. Same thing, neutron is neutral. A proton also carry a charge 1.6 into 10 to the power minus 19 coulomb. But the only difference is the nature of the charge. Proton is positive, where electron is negative. And for an atom, the number of the proton are equal to number of electron. That's why the whole atom is neutral. But what will happen? What will happen when atom lose electron? So as the atom lose electron, what will happen? It will have more protons than electrons, as it is losing electron is, because in the shell, so it can be easily lost or gained from by the atom. So it will have more proton than electrons. If it will have more proton than electron, the charge will be the charge which will appear on the atom will be positive. So example, if I say this is a nucleus. Inside the nucleus, I have 11 protons and I have 12 neutrons. And around the nucleus, electrons are there. In a definite region, we call them as a shell. First shell, it will have 2. Second shell, it will have 8. And third shell, it is having 1 electron. Now what happened, as number of electron and number of protons are same, so this is neutral. Now what happened, if it lose electron, so when it will lose one of the electron, what will be the charge appear now? The central part is a nucleus. There are 11 protons and there are 12 neutrons, and around the nucleus, electrons are there, but one of the electron being lost. Say this is the last shell electron and that is being lost. So what will be the charge on this? Which is having 11 protons and 10 electrons. What will be the charge, positive or negative? So it will be positively charged. Why it is positive charge? Because you can see here, white was neutral. The number of the protons were equal to number of electrons. But why it is positive? So number of protons are more than number of electrons. So as the distribution of proton to electron changes, the atom will have a charge on it. So it will appear as a charged particle, not a neutral atom. Is it clear, this part? Is it clear why, how we can charge an atom, like, or how we can charge a material? That's the next topic. But first thing you should understand that atom can have a positive charge. How atom can have a positive charge? By losing electron. Same way, what will happen when it will gain electron? So when it will gain electron, it will be negatively charged. Why it will be negative charge? Example, you have an atom which is having 9 protons, 10 neutrons, and 9 electrons. What is the charge on this atom? What is the total charge? Positive, negative, or neutral? It is having 9 protons and 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons. So electron and protons are same. So if 9 proton and 9 electron, so if number of proton and electron are same, then it will be a neutral particle. So it does not have any charge. It is neutral right now. But what happens if it gain electron? Like there's an extra electron it take. So when it gain that extra electron, so the charge appear on this will be negative. Why it will be negative? Because the number of the protons are less and the number of electrons are more. So the negative charge increases. That's why the net charge, there are charge particle, there are positive charge particle, but the net charge, the resultant charge is negative. So 9 protons, neutron does not contribute to charge, but because it took extra electrons, so as it take extra electrons, so what will be the charge appear? The charge appear, now it is having more elect or proton, number of proton are less than number of electron, so the net charge will be negative. So we can change the distribution between the proton and electron inside an atom. And how it can be done, how we can charge an object. There are two ways to charge an object. Number one, by friction. Number two is by induction. So if we want to make an object charge, so what can be done? There are two ways to charge an object. One is known as friction, and the second one is known as induction. What happens in friction? Charging by friction, what we do when two objects are rubbed together, or two surfaces are rubbed together, it produces heat which allow electrons to move from one surface to another. The surface which lose electron is positively charged, and the surface which gain electrons will be negatively charged. So example, say you have a cotton and you have a plastic, another object is made up, it should be two different objects, not identical object, because if identical objects are there, they both have the same tendency, so this technique will not be effective. It will work but not be effective. But when two objects are there of different nature, like example, you have a cotton, another one is plastic. Now what you are doing, you are rubbing them together, to and fro you move, so you rub them together. When you rub them together, what it produce heat, because there's a friction between the two surfaces, and what friction will cause, friction will provide heat energy, and that heat energy is absorbed by these atoms. So atom contain basically neutron, proton and electron. So when heat energy is absorbed by the atom and the particle inside the atom, which is electron, so these electron, the material in which electron are loosely bonded or electrons have weak attraction towards the nucleus, so that material will lose electron. So example, when we rub cotton with plastic, the plastic is having a weakly bonded electron, so when we rub them together, the electron actually jump, I'm just drawing the electron, not the whole atom. Electron actually jump from plastic to cotton surface. So after rubbing this, when we rub them together, what will be the charge on the plastic? what will be the charge on the plastic? The net charge. So as it is losing, or there is a loss of electrons, so when it is losing, or if it's a loss of electron, so what will be the net charge? Net charge will be positive due to loss of electron. There are other atoms are there, but majority of them, yes, you can rub any two surfaces, this will work, but it depends, like effectively it depends on the nature of the atoms, like the bond, the strength of a bond or attraction of the electron from its nucleus. So if greater attraction is there, it will be difficult to remove electron. If weaker attraction is there, this process will work effectively. So when you rub, plastic will lose electron, the net charge on the plastic will be positive, and the cotton gain electrons. So what will be the net charge on the cotton? That net charge will be negative. So this method by which we rub the two surfaces and the object is charged, how does the heat look? Heat is a form of energy. So what happened when you're rubbing the two surfaces, it produces heat, and that heat causes the speed or the temperature of the surface increase. So when it produces heat, because heat is a form of energy, so when increase in heat, it means the particle will move faster. As a particle will move faster, more likely the electron transfer or electron gain energy and can move from because of that heat. How we can know which material? Yeah, the question is how we will know whether a electron transfer from plastic to cotton, or why not it move from cotton to plastic. So basically it depends on the strength of or the force between the nucleus and the electron. If this force between the nucleus and electron is stronger, then, like example, when I compare, because cotton also consists of atoms, plastic also consists of atoms. So when you're rubbing them together, here I assume that the plastic electrons have a weaker attraction. That's why the electron transfer from plastic to cotton. But it can be other way around. It's not a fixed rule that this will happen. Actually, it depends on the type of the surfaces which you are using. The surface which is having a weaker attraction towards the electron, that surface will lose electron easily. But you don't have to memorize which surface will lose, but you have to understand the concept that the surface which lose electron will be positive charge, and the surface which gain electron will be negative charge. Same way, if you repeat this process, like example, now you're taking a cotton, the same cotton you're taking, which is neutral originally, and instead of plastic, you're taking a rubber, and you rub them together. When you rub them together, now you observed actually the electron transfer from cotton to rubber. So what will be the charge on the cotton now in this example? If the electron transfer from cotton to the rubber, what will be the charge on the cotton surface? It is losing electrons. So when it is something lose or loss of electron is there, so it will be positively charged. So in this example, the cotton will be positive and the rubber will be negative. So you can see in the first example, the cotton was negative, but in the second example, cotton is positive. Why it is like this? Why not every time the cotton is negative? Because it depends on the force of attraction between the electron and the nucleus in the two materials. The material in which the atom is having a weaker, the nucleus is having a weaker attraction to the electron, that material will lose electron and likely to form a positive charge. Is it clear? Electrostatic friction. Any doubt in this part? So basically, according to law of electrostatic, according to law of electrostatic, it said like or same charges repel each other, or unlike or different charges attract each other. So if identical or same charges are there, they will repel each other. Like example, if I have a positive charge and I place next to another positive charge, what they will do, attract or repel? The two positive charges are there, the like charges. So the two identical or like charges repel each other, means they will move away from each other. Same way, if we have positive and negative unlike charges, what they will do? They will attract each other, move towards each other. And if we have a positive, a negative, two negative charges are there, if two identical or negative charges, they will also repel each other, they will move away from each other or push each other away. So this is known as a law of electrostatic, that if two same charges are there, they will repel, and if two opposite charges are there, when something is a law, it means practically all the scenarios, all the cases, it is valid. There's a difference between law and theory. Like theory means it's just a suggestion, but practically it's not proven, like all the scenarios. But when something is law, it means practically it is coming out for all the scenarios, all the condition, it is valid. So example, you have two surfaces. This is surface A or material A, and you rub this surface A with surface B. Okay. And then after rubbing, because when you rub, the electron will transfer, but you cannot see the electron transfer. You cannot see with the naked eye the electron. So you don't know which one is positive and negative. But then what you did, you take a charged sphere. You have a positive charged sphere, and you bring this rod B, after rubbing, you bring this rod B closer to positive charge sphere, and you observe that this charge sphere move away from rod B. So this charge sphere move away from rod B. Now my question is, what is the charge on A and what is the charge on B? First, what is the charge on A? Charge on A. So charge, because basically what happened, if it is repelling, we can conclude B is positive. So if B is positive, it means A should be negative. And how we conclude B is positive? Because when we bring B closer to another charged sphere, positively charged sphere, it move away or it is repelling each other. So what is the charge on A? So the charge on A is negative. And what is the charge on B? What is the net charge on B? So B is positive. What is the direction of electron transfer from A to B or B to A? Which direction the electron transfer? So because B is positive and A is negative, so it shows B is losing electron and A will gain electron. So direction of electron transfer is from B to A. Is it clear, this example? So you will find similar question in exam past papers, that you have to identify the nature of the charge by a small experiment related to electrostatics. Is it clear, this example? So this is the first method of a charging. If you want to charge an object, you can charge by the second method is known as charging by induction. The term induction means it is from production, like in this way, when object is charged by the help of another charged object. So when object is charged by the help of another charged object, we call this process as induction. And this induction can be used to charge, commonly it can be used to charge metal. Other materials can also be charged, but commonly it is used to charge the metal. Example, this is a metal sphere. As we discussed in chemistry, the metallic bonding, what is a metallic bonding? Metallic bonding means a lattice of a positive ion, means regular arrangement of the positive ions and the delocalized electrons. That's called metallic bond. Inside a metal, already electrons are moving, electrons are free to move. So this is a metal which is having a lattice or regular arrangement of the positive charges. So regular arrangement of the positive charges and delocalized electron. I drew a space, like I provide a gap here, but like original structure does not have a gap. Just for explanation point of view, I use this gap. So what is there in this, inside this gap, like within this gap, the red shade is representing what? It is representing electrons. Means like electrons can be anywhere within these spaces. They're continuously moving within these spaces and not in a specific direction. Randomly these electrons are moving. So the red shade, the red color is representing the delocalized electrons. Delocalized means does not have a fixed position. This positive charge is having electrons as well, but this is a net positive charge. Like it is having electrons, with atom lost its electron, so it is having, still there are electrons, but number of the protons are more than number of electrons, so it is net or resultant positive charge. Overall metal is neutral because the number of positive and negative charges are same.
Sir, I'm sorry.
Yeah.
The net charge in this metal sphere, it's neutral, right?
Yeah, metal sphere. The net charge overall metal sphere is neutral because the number of the positive ions.
And
This is
then it's okay, sir. Clear. Thank you.
basically positive ion. Maybe if I was writing charge, so maybe was confused about the sphere. So overall, metal is neutral. The metal sphere because the positive ions are equal to number of electron delocalized electron. Yeah. These the question is like how these electrons are able to remain inside the metal. They can is why don't they escape or move out? Basically, these electrons can escape, but they need some energy. So you can, if you heat a metal, like metals are there, if we heat, if the metal remain in solid state, but if we supply too much heat energy, an electric field is also there, so we can remove this electron out. But strong attraction is there, so normally at room temperature electrons are not going out, but there are ways. If you supply heat energy to the metal and electric field, you can remove these electrons out, which is called thermionic emission. So all these metal spheres overall in the beginning, they all are neutral. They have equal number of positive ion and the delocalized electrons. But what is electrostatic? What is the meaning of electrostatic? Now what we will do, example, when object is charged by the help of another charged object, this is called electrostatic induction. So I bring a charged rod here, I bring a positive charge rod. Like a rod already I made it positive. So what happened? According to law of electrostatic, like charges attract and unlike charges repel each other. So as the like charges repel and unlike charges attract each other, so what happened? Electrons are attracted towards the charge rod. This is a charge rod which we bring. So electrons are attracted because unlike charges attract. So electrons attracted towards the charge rod, then majority of electrons move towards the charge rod. The positive ions, because it is a lattice means regular arrangement of the ions, so positive ions cannot move, and the positive ion experience a repulsion from the charge rod but cannot move due to the lattice, like the regular arrangement of the ions. And this will create distribution of charges. So basically what happened in the beginning, when the charge rod was not there, electrons were moving randomly. But as we bring the charge rod, So as we bring this charge rod, electrons are actually moving towards one side. So as the electrons are moving towards one side, so what we observe that as these electrons move towards one side, so majority of the electron shifted towards right hand side. In this example, majority of the electrons shifted towards right hand side. So as majority of the electrons are shifted towards right hand side, what it create a distribution of the charge. Like most of the electrons are towards right hand side, there are few electrons on, because positive charge, unlike charges attract each other, positive charge dot attract electron. So as it attract electron, majority of the electron will move towards right hand side in this example. As majority of electron move towards right hand side, so on the right hand side, what is the resultant charge? Like if I divide this sphere into two halves, on the right hand side, majority of the charges will be positive or negative. So majority of the charges will be negative. On the left hand side, majority of the charges will be positive. So this create a distribution of the charge. When we create a distribution of the charge by the help of another charge object, what we call this process? We call this process as electrostatic induction. It's a method by which we separate the charges, or an object is charged by the help of another charged object. We call that as electrostatic induction or charging by induction. But the moment I remove this charge rod, like example, if I remove this charge rod again, what happened? Again, it will be distributed. So it only create a distribution of the charges in the presence of the charge object. If the charge object is not there, then this distribution will be same again. So the moment we bring the charge rod, and if I bring a negative charge rod, which side will have more electrons? Right hand side or left hand side? These are the positive ions. Which side I will have electrons, majority of electrons, on the right hand side of the sphere or the left hand side of the sphere? So on the left hand side, majority of the electron will be there on the left hand side. So most of the there will be electrons on the right, but most of the electrons are towards the left hand side. So what is the net charge on the left hand side? The net charge will be negative. And what is the net charge on the right hand side? That will be positive. So this method is known as electrostatic induction. So we started this topic by the concept of atoms, then positive and negative ions, and how we can charge an object. The first method is known as a friction, and the second method is known as induction. Induction means when you bring a charge object, you create a distribution of the charge within the material, and this distribution, the process is known as electrostatic induction, in which the object is charged by the help of another charged object. I will complete the explanation in the second session. I will share the link once this will end.